On September 5, 1977, NASA launched a spacecraft that would go on to become one of the most legendary achievements in human space exploration, Voyager 1. What began as a mission driven by Cold War tensions and a thirst for discovery during the golden era of planetary science, turned into something far greater. Voyager 1 wasn't just meant to study planets, it became a time capsule of human civilization and an ambassador to the stars. It was equipped with what was then cutting-edge 1970s technology, including magnetic field sensors and imaging cameras. At the time, no one could have imagined how far it would truly go. Voyager 1 was part of a twin mission, its counterpart being Voyager 2. These two probes were designed to take advantage of a rare planetary alignment that happens only once every 176 years. This alignment allowed them to perform a grand tour of the outer solar system. By using gravity assists, essentially slingshot maneuvers around planets, they could conserve fuel while extending their range to visit multiple gas giants. This brilliant trajectory planning enabled both spacecraft to gather incredible data that reshaped our understanding of the solar system. Each probe had a unique mission path designed to maximize scientific return. Voyager 1's journey was optimized for a close encounter with Titan, Saturn's fascinating moon rich in methane. Meanwhile, Voyager 2 was aimed at Uranus and Neptune, the more distant gas giants. This division of labor allowed NASA to extract maximum scientific value from both missions. As Voyager 1 zoomed past Titan, it gathered data that would later change how we viewed not only moons but the possibility of life beyond Earth. Ultimately, Voyager 1's path flung it out of the planetary plane, setting it on a course toward interstellar space, a destination no human-made object had ever reached before. Even more impressive is the fact that Voyager 1, now billions of kilometers from Earth, runs on a computer with less processing power than a modern calculator. The data it sends back to Earth travels at just 160 bits per second, a speed that would seem laughable by today's internet standards. But in those trickles of information lies a wealth of knowledge. Despite its limitations, this spacecraft discovered volcanic eruptions on Jupiter's moon Io, detailed Saturn's complex ring structure, and identified organic molecules on Titan. These discoveries were not just impressive, they fundamentally shifted theories about moon formation and the potential for habitability within our solar system. Voyager 1 was originally expected to operate for just 5 years. Yet, more than 4 decades later, it continues to function, a testament to NASA's ingenuity. It has survived conditions that would destroy most machines: intense radiation belts, micrometeoroid strikes, and the frigid cold of deep space. In 2012, Voyager 1 crossed a defining boundary known as the Heliopause, the edge where the solar wind from our sun meets the interstellar medium. That moment marked humanity's first physical entry into the vast and mysterious space between stars. It was more than a technical milestone, it was a cosmic leap forward for all of us. Crossing the Heliopause wasn't just symbolic. Voyager 1's instruments recorded a dramatic change in radiation levels, providing solid evidence that it had exited the sun's protective bubble. The spacecraft's cosmic ray detector captured a surge in high-energy particles that originate from ancient supernovae across the galaxy. This confirmed that the solar system's boundaries are not fixed, but instead breathe and shift depending on solar activity. Renowned theoretical physicist Michio Kaku has called Voyager 1's data a treasure trove for understanding how our sun interacts with the galactic environment. It's changed how scientists view the solar system's role in the broader cosmic neighborhood. And the discoveries didn't stop there. In recent years, Voyager 1 has picked up strange plasma oscillations in interstellar space. These fluctuations in charged particles create eerie rhythmic sounds, sometimes described as interstellar thunder. By studying these plasma waves, scientists can estimate the density and structure of the space between stars, revealing unseen magnetic fields and ionized clouds. But not all signals are fully understood. In 2020, Voyager 1 detected repeating pulses that lasted for weeks. These puzzling patterns don't fit neatly into known models, sparking fresh debates among astrophysicists about what exactly Voyager is sensing out there. One idea suggests Voyager 1 might be detecting interactions with dark matter, the mysterious substance that makes up most of the universe's mass yet remains invisible. While Voyager 1 doesn't carry any instruments specifically designed to detect dark matter, anomalies in its particle data could hint at gravitational effects caused by dark matter clumps or filaments. Others believe the signals could be echoes from distant neutron stars or even primordial black holes, tiny remnants from the early universe. These are speculative theories, yes, but they highlight just how much Voyager 1 has transformed from a planetary scout into a deep space detective. As if its scientific legacy wasn't already remarkable, Voyager 1 also carries something profoundly human. Attached to the spacecraft is the Golden Record, a 12-inch gold-plated copper disc curated by Carl Sagan and a dedicated NASA team. The record contains a selection of sounds, images and greetings from Earth, meant as a message to any extraterrestrial beings who might find it. It includes everything from whale songs and thunder to greetings in dozens of languages and Chuck Berry's Johnny Be Good. Though it's unlikely any aliens will stumble across it, the Golden Record represents humanity's hope to connect with the cosmos in a meaningful way. Even the sounds recorded by Voyager 1 are surreal. Its plasma wave instrument converts electron vibrations into audible frequencies, producing haunting songs from interstellar space. These noises often resemble raindrops hitting a metallic surface, hinting at the dynamic chaos that exists in the void between stars. In 2023, researchers noticed that these sounds weren't entirely random. Patterns began to emerge, some rhythmic, others pulsing, raising questions about possible magnetic reconnections or even unknown forms of turbulence in interstellar plasma. Each new finding adds another layer of intrigue, reminding us how little we truly know about the universe that surrounds us. Voyager 1 is powered by 3 radioisotope thermoelectric generators, or RTGs, which convert heat from the decay of plutonium-238 into electricity. But like the spacecraft itself, these power sources are aging. Each year they produce about 4 fewer watts than the year before. This slow decline in power has forced NASA to make difficult decisions, shutting down non-essential instruments to preserve the core systems. By 2030, it's expected that Voyager 1 will fall silent, no longer able to communicate with Earth. But even when that day comes, its legacy will continue. The information it has already sent back has reshaped science forever and will guide future missions for decades to come. Voyager 1's incredible journey has influenced many missions that followed, including the famous New Horizons spacecraft that flew past Pluto, as well as ambitious future projects like the upcoming Interstellar probe designed specifically to explore the space beyond the heliosphere. This vast region marks the boundary where the sun's influence ends and interstellar space begins. But operating a spacecraft so far from Earth comes with huge challenges. Communication delays are one of the biggest hurdles engineers face. Signals traveling at the speed of light take over 19 hours to reach Voyager 1, and the same amount of time is required for a response to come back. This means every command sent to Voyager 1 must be planned months ahead, with careful anticipation of potential problems. Adding to the complexity is the fact that Voyager 1's onboard systems run on software from the 1970s, patched with modern updates over the decades to keep it functional. This delicate balance of old and new technology is a remarkable example of human ingenuity operating under extreme constraints. Thanks to this blend of vintage and updated tech, NASA has managed to keep Voyager 1 operational far beyond its expected lifespan. One of the most iconic images Voyager 1 ever took is the famous pale blue dot photo, captured in 1990 from about 3.7 billion miles away. In that image, Earth appears as a tiny speck suspended in a sunbeam, a humbling reminder of our fragile place in the vast universe. Carl Sagan famously described this photo as a mote of dust suspended in a sunbeam, which inspired deep reflections worldwide about environmental responsibility and human unity. More than any graph or data plot, that single image captures the philosophical heart of the Voyager mission. But Voyager 1's journey has also revealed real cosmic dangers that future astronauts will face. Beyond the Heliopause, the probe is bombarded by galactic cosmic rays, high-energy particles moving at nearly the speed of light. These particles pose serious risks to both spacecraft electronics and biological systems. By studying how Voyager 1 withstands this harsh environment, scientists are learning how to better shield future missions to Mars and even farther destinations. Voyager 1's durability in such hostile conditions offers hope that interstellar travel, though daunting, is not impossible. However, in 2022, the mission faced a critical scare when Voyager 1 began transmitting garbled data from its attitude control system, which helps the spacecraft orient itself. Engineers quickly traced the problem to an aging computer chip. Demonstrating incredible creativity, they devised a software workaround that bypassed the faulty component. This fix, dubbed the Miracle Patch, extended Voyager's mission once again, proving that even 50-year-old technology can adapt to unexpected challenges millions of miles from Earth. Interstellar space itself is not an empty void but a complex region filled with neutral hydrogen gas, dust grains and magnetic filaments. Voyager 1's measurements show that this area is actually less dense than previously predicted, revealing significant gaps in existing models of galactic evolution. Some scientists believe this low-density region could be a local anomaly, while others think it reflects much larger cosmic structures we have yet to map. Adding to the mystery, Voyager's magnetometer detected surprising magnetic field alignments in interstellar space. Contrary to expectations that these fields would be chaotic and turbulent, they appear ordered and aligned with the overall shape of the Milky Way galaxy. This finding could dramatically change how astronomers understand galactic magnetic fields and their influence on star formation. One of the biggest scientific questions still tied to Voyager 1's data is the nature of dark matter. If Voyager's instruments detect unusual particle accelerations or behaviors, it might hint at clumps of dark matter nearby. Although indirect, such evidence could validate major theoretical physics ideas like supersymmetry or axion particles, potentially solving one of the greatest mysteries in science. Until such a breakthrough happens, researchers meticulously analyze Voyager's data, searching for subtle statistical anomalies that could reveal this hidden cosmic component. Meanwhile, alien hunters and SETI scientists have speculated about the strange signals Voyager 1 detects, but most experts urge caution. Many anomalies can be explained by natural astrophysical processes like solar flare remnants or shocks in the interstellar medium. Despite these mysteries, Voyager 1's long life provides an unparalleled opportunity to study the effects of long-term space weathering on both hardware and materials. This information is crucial for designing the next generation of deep space probes that will venture even further. As Voyager 1 continues drifting toward the Oort cloud, a vast shell of icy bodies surrounding our solar system, it may eventually provide new insights into this distant region, although it won't reach it for another 300 years. Meanwhile, the data Voyager sends back helps refine models of the Oort cloud structure and its role as a source of comets visiting the inner solar system. Each bit of information is a vital piece of our cosmic timeline. Voyager's success has inspired visionary projects like Breakthrough Starshot, which aims to send laser-propelled nanocraft to Alpha Centauri, our nearest star system. These missions, building on Voyager's legacy, seek to answer some of humanity's biggest questions. Does life exist beyond Earth? And how might humans one day colonize the stars? Voyager 1's story proves that with ambition, perseverance, and clever engineering, what once seemed like science fiction can become reality. Over its 45-year journey, Voyager has forever changed humanity's view of the cosmos, from revealing active volcanic moons to capturing the profound silence of interstellar space. As Voyager 1's power gradually fades, the probe will transition into a silent ambassador, carrying Earth's story into the vast galactic wilderness. Its final signal, whenever it comes, will mark the end of an era in space exploration, but also the beginning of a new chapter. For all the wonders Voyager 1 has uncovered, there is still so much more to explore. Stay curious and remember that every great journey begins with a single step, or in this case, a tiny probe hurtling through the stars. Thanks for watching, and don't forget to subscribe to our channel for more incredible stories from the final frontier.